Hi, I am T. Kavita, Assistant Professor, Department of Mathematics. Today's topic is composition of function. Composition of function. In mathematics, the composition of functions means combining two or more functions so that the output of one function becomes the input of another function. Composition of functions combines two functions to form a new function. If f maps a to b and g maps b to g, then g composition f maps a to c. If f of x and g of x are two functions, then the composition of f and g is written as f composite g of x is equal to f of g of x. This is read as f composed with g. It means first apply function g, then apply function f to the result. Domain of g composite f is equal to domain of f. Next, process of composition of function. To find f of x, to find g composite f of x, first step, take x from a. Second one, apply f to get f of x. Third one, take f of x and apply g. The final output is g of f of x. That is, g of f of x is first, g of x is first operation, f of x is second operation. Then f composite g of x is equal to f of g of x. Similarly, we can find g of f of x is equal to g composite f of x is equal to g of f of x. In most cases, f composite g of x is not equal to g composite f of x. Here we have this simple idea, that is, think of composition like a machine process. Input is given function g, that's the result. Next function f is the next step. Next, final output. Here we can see the example. Let f of x is equal to 2x plus 1. G of x is equal to x square. Now we can calculate g composite f of x. G composite f of x, we first find f of x, therefore g of f of x. Here f of x value is 2x plus 1, therefore g of 2x plus 1. G of x is here x square. Now we can find g of 2x plus 1. Now the result is 2x plus 1 the whole square. This is the first example. Next, this is the out map for composition of function. F composite g of x, that is f of g of x. Here the two functions are g of x is equal to x minus 1, f of x equal to 2x. These are the two functions. First we calculate g of x, therefore f composite g of x is f of g of x. Always to right to left we can calculate, therefore g of x is equal to x minus 1. Next we can find the f of g of x. Here there are some examples in numbers. F of g of 5. Here g of x is equal to x minus 1. X is 5. Therefore 5 minus 1 is 4. Now we calculate f of g of 5. F of 5, g of 5 is equal to 4. Therefore f of 4 is equal to, here f of x is equal to 2x. Therefore we can multiply by 2. F of g of 4 is equal to 8. At the same we can calculate g of 7 and g of 3. Here g of x is the domain, range of x, g of x, and domain of f of x and range of f of x. This is the example 2. Let f of x is equal to x minus 3, g of x is equal to 5x. Compute f composite g of x. F composite g of x is equal to f of g of x is 5, therefore f of 5x. Here f of x is equal to x minus 5. Now we calculate f of 5x, therefore 5x minus 3. Here g composite f and f composite g are usually not equal. We already said that. Next, functional mapping. The functional mapping, we here give the set A is equal to 1, 2, 3, set B is equal to 2, 4, 6, set C is equal to 4, 8, 12. Here the mapping, the function f is 1 to 2, 1, 2, 2, 4, 3, 6. That means image of 1 is equal to 2, the image of 2 is equal to 4, the image of 3 is equal to 6. Now the function g is equal to 2, 4, 4, 8, 6, 12. Here f of 2 is equal to, g of 2 is equal to 4, g of 4 is equal to 8, g of 6 is equal to 12. Now we calculate the composition g composite f. Here the function 1 image is 2, 2 image is 4. Therefore G composite F of 1 is equal to 4. Then 2 is mapping, 2 image of 2 is 4, image of 4 is equal to 8. Therefore G of F of 2 is equal to 8. Again the number 3, the 3 F of 3 is equal to 6, F of 6 is equal to 12. Therefore G composite F of 3 is equal to the mapping 1, 4, 2, 8, 3, 12. Therefore G composite F of 1 is equal to 4. G of F of 1 is equal to 4. G of F of 2 is equal to 8. G of F of 3 is equal to 12. This is the functional mapping example. Next, this is the graphical interpretation. Functions can be visualized as arrows connecting sets. Composition changes these arrows into a single mapping from the first set to the last, useful in transformation, geometry, and computers. Properties of composition associative. This is not commutative. We already said that. Here we are using three functions. H composite G composite F is equal to H composite G composite F. Then the not commutative is G composite F is not equal to H F of F composite G. Identity function acts as a neutral element. This is a key concept. Operations on functions. Let f and g be any two functions. A new function it can be defined by performing any of four basic operations on f and g. Here addition, that we take the h of x is equal to f of x plus g of x. Now we can add two functions like that. F of x equal to 5x, g of x equal to x plus 2. Now we can add 5x plus x is 6x plus 2. Therefore h of x is equal to 6x plus 2. At the same we calculate subtraction and multiplication and division. The domain of h contains of the x values that are in the domains of both f and g. Additionally, the domain of the quotient does not include x values for which g of x is equal to 0. This is the key concept. This is the summary. Composition combines two functions into one. F composite G of f of x is equal to G of f of x. Order of a composition is important, widely applicable in mathematics and computer science. Here graphical understanding, if G of x changes the input and f of x changes the result again, the composition represents a sequence of transformation. Composition of function is widely used in a daily life, business, engineering, economics, and computer science, that is banking and finance. Suppose one function calculates interest, another function deducts tax. Banks use composition for loan calculation, interest processing, tax deductions, and investment growth. And online shopping also, one function adds GST, another gives discount. Here advantages of composition of functions: simplifies complex operations, helps model real world systems, useful in automation, saves computation time, important in advanced mathematics. Thank you.